Alright, check whether kth bit is set or not. Cisco. And so this is Bitmagic, and this problem is related to Cisco. Given a number n and a bit number k, check if the kth bit of n is set or not. A bit is called set if it is 1, which is like, I always think of it as meaning it is on. Position of set bit 1 should be indexed starting with 0. From the RSB side, in binary representation of the number, consider n equals 4 times 100. 0th bit equals 0, first bit equals 0, second bit equals 1. Wait, what? I don't understand that. Consider 4. What's the 4 doing there? RSB. Starting with 0 from the RSB. I actually don't know what RSB means. Right side? I think it's right side. We'll go with right side for right now. Right side of binary, I don't know, side and then binary. And we consider n equals 4. 0th bit is 0, first bit is 0. Oh, I see what they're saying. Right, so 0th bit is 0, first bit is 0, second bit is 1. I don't know what this 4 is. Okay, input. The first line of input contains an integer t, denoting the number of test cases. So if I look at an example here, we have 3 test cases. Each test consists of 2 lines, so since we have 3 test cases, we should have 6 total lines. So we have 3, so 3 times 2 is 6. Each test case consists of 2 lines. The first line of each test case contains an integer n. The second line of each test case contains an integer k. So that means n is the number of times that you n is your number. Yeah, n is your number. K is the kth bit. So like, this is the 0th bit, this is the second bit, this is the third bit. And output is no, yes, no. What are we outputting? Corresponding to each test case, print yes without quotes if the kth bit is set. Else print no. Oh, you're checking if it's set. Oh, okay. So for 4, the 0th one is not set. For 4, the second one is set. For 500, I have no idea, but I guess the third one is not set. Oh, that's what this meant over here. The binary representation of 4 is 100. From the LSB is not set. Okay, so that's from the LSB. So that's from the LSB. And what was this about the RSB? Position of set bit should be indexed starting 0 from, I don't know, it says RSB here. But this says the 0th bit from the LSB is not set. I don't know why they switched it. Let's do this in Python. So my code just goes here. Right. Okay, so I'm going to define a function. Check kth bit. Check set. Kth set. We're going to just say check kth set. And we're going to take an input of the number n and the k. Okay, so this will be the function. Before I get into the function, let me take the input. So we're going to have cases equal to int of the input. And I have to go through it for a range of cases. Then I would say it's going to be like that. Okay, so n is equal to int of input. K is wait, which one comes first? Was it n or k? Yeah, okay, so the first one is n. Second one is k, so input. And then what you can do is basically, once you do that, you can just print check kth set in and k, and you're all set. So now I decided to create this function to do what we needed to do. So what I'm thinking I'm going to do is I'm going to, well, here. So let's take the first example, like 4 and a 0. So we have 4 and 0. So the 4 in binary is 1, 1, 0. And if we want to check if the kth one is set or not, we could just do 1 and we would get 0, right? Now let's say we're taking 4 and we're checking the 1, the 1th one. We would have 1, 1, 0, 1, 0, and and this would give 0 and 1, and I don't know. So I guess this is 0, and this is 0, and this is 0. So this is 0, 0. And this is greater than 0. This is equal to 0. So if the kth one is set, you should always get something greater than 0. If it's not, it won't. I can do another example. Let's see. So the other example is 500. I'm not going to do 500. That's too great. So yeah, I think this will work. So I'll just go and do it. So it's just a basic thing. So it'll be return yes. I think it's return yes. Yeah, return yes. If, or maybe, well, yeah, you have to return yes. If n and 1 is, this is if it exists, right? So if it's greater than 0, else it's no. That should be it, yeah. So this is going to be greater than 0 if the kth bit is set. If it's not set, it'll be equal to 0, and I should return no. So we can do this. We can create our own input. So let's say I do 3 inputs, and I'll do 8, wait, what am I doing? 8, 4, 16, 3, 2, and 0. No. Is that right? That might be right. Because 8, I think, is the 4th one. No, wait, that's wrong. 8th is the 4th one, right? Because it's 1, 2, 4, 8. That's not right. What's going on? So if you have 8, 8 is this in binary, and then if you're using 4, 4, so you're setting the 4th digit. So you would be taking 1, shift it over 4 times, which would be 1, 0 is 1 shift, 1, 0, 0 is your second, so 1, 2, 1, 0, 0, 0 is your third, 1, 0, 0, oh. So I guess you have to do 1 minus. Yeah, that makes sense because, or keep this as k, but then here at the input, subtract it by 1. Okay, that should work. So it should say yes for one of them.